Unit 6, Day 3, Correlation and Line of Best Fit. So recall that scatter plots show a relationship between two sets of numerical data. And then a definition. A correlation is always a way of describing the pattern in the scatter plot. So there are a few types of correlations that you might see when analyzing a scatter plot. The first one is a positive correlation. So its pattern slopes up and to the right. So both quantities, so these quantities and these quantities, increase together. Now a negative correlation is the opposite. It slopes down and to the right. So as one quality increases, the other decreases. And finally, no correlation just means that there's no pattern at all between the points. So another way to describe a correlation between two sets of data is to look at how close a line the points make when plotted. So a strong correlation is a scatter plot that has a line-like or linear shape to it, similar to the negative correlation pictured earlier. So this would be a strong correlation because they are very linear. They look like they form a line. A weak correlation is a scatter plot that has points that are spread out, but there is still a pattern, similar to the positive correlation in the example pictured earlier. So here you can see that there's definitely a pattern. They're all increasing, but the points are more spread out than they are in a strong correlation. The next topic we're going to introduce to you is called the line of best fit. So this is a line that is drawn on a scatter plot to help illustrate any trends in the data. So as you can see here, we have some data, and this blue line is our line of best fit. So when you draw a line of best fit, there's a few rules you must follow. First of all, the line of best fit should pass through as many points as possible. So as you can see here, they're through this point, almost to that point, and these points as well. So that just makes the line as accurate as possible. Secondly, there should be an equal number of points on each side of the line. So there should be an equal number of points on this side of the line as well as on this side of the line. And finally, the points should be spread out along the line, not clumped at the end, which again you can see is happening in the example above. So let's keep those three rules in mind when we're doing the next few examples. Example 1. Several MPM1D students were surveyed to see how MSN affects their math mark. The results are given in a table below. A. Draw a scatter plot for this data. So as you can see on this chart, we have the students who are denoted as numbers. We have their marks below, and then we have the number of hours they spend on MSN. So first, let's draw a scatter plot for this data. So on part A here, we have drawn a scatter plot for the data. Now we're asked to describe any trends that are evident within that data. So the first thing that we should notice from above is that there is a weak and negative correlation because as the time on MSN increases, the marks decrease. Part C. Draw a line of best fit. So as you can see, I've added a line of best fit on this graph. So I've tried to go through as many points as possible as well as have an equal number of points on each side. So finally, we can use the line of best fit to actually make predictions about the graph. So for example, interpolating, predict a point that is within the range of data that was recorded using the line of best fit. So for the example they're giving here is they're saying they could predict that somebody who spends an hour and a half on MSN, we just go all the way up to when we hit the line of best fit, and then we go across and we notice that they would likely get a mark around 85%. We also have extrapolating, which is predicting a value of a point that falls outside of the range of data that was actually recorded by extending the line of best fit. So for example, someone who spends 4.5 hours on MSN, that time is outside of the data that we're given, but if we draw a line up to our line of best fit, we can see that that person would get about 65% in their math class. So this is one of the ways that a line of best fit can help us to predict other information.